Hey guys, today we are going to cover the concept of sets. So, a set is a container of elements that are distinct. So, um, the way you write a set, here's a specific example. You can have three elements, A1, A2, and A3. Okay. So, one thing that characterizes a set is that you have um, bracket not bracket braces uh, on both sides of the elements, and then you can name a set anything. It can be called A, B, C, or anything else. One thing interesting is that you can have um, uh, different different element within a set. Okay, or you can compare sets. In which case you can have, um, say for instance, you have another set called B, which is A1. Okay, in this case, you can say that B is included in A. Why? Because A1 is an element that belongs to the set A. Okay, all right. So let's cover another uh, topic here. Um, we have we just talked about the inclusion, but let's talk about now um, a basic example. Okay, so if I have I was just wanting to show you the big picture. So this is the universe, okay? And I have a set. In some cases, you can have a set A, okay? And that set A is contained in a bigger set, which is called B, okay? How would you uh, describe the relationship between A and B? It's really simple. Here, you can say that A is included in B. So this is pretty much uh, the mathematical uh, representation of what you see in this chart here. All right, so this is the inclusion, and let's talk about now the union. When we talk about union, uh, we want pretty much want to look at um, the element that are either in one element or the other or both. Let me give you an example. So, say for instance, you have two set A and B, okay, and you have a universe S. Okay, let me draw what's called a Venn diagram. All right, and in this Venn diagram, you have set A and set B. The union of these two sets will definitely be anything that belong to A, anything that belong to B, or both at the same time. So you, the part of A is here, is all this. The part of B is all that, and the part that belong to both at the same time is this is the middle. So the union will consider the red portion, the blue portion, and the red and blue portion at the same time. So that's what called that's what's called the union, and the union between two sets in the mathematical translation is AUB. That's pretty much how it's included. Okay, um, that's how pretty much how it's represented. All right, so let's talk about the intersection between two sets. When you talk about intersection, it's pretty simple. Let's consider again the same two sets, A and B. The intersection is the element that belong to A and B at the same time, and not only A and not only B. So, drawing again my Venn diagram. Okay, what are the elements that belong to A and B at the same time? This is this portion here, and when I label, uh, this is my A and this is my B, and then my intersection would be A intersect B. So this is the intersection notation, which is a reverse U. Okay. Um, Now let's talk about now the the I would say not really the complement. Yeah, but let's talk about complements. All right. So when you think of complements, uh, let's all let's yep. When you think of complements, let me erase this first. You can think of complement as whatever is not in the set. Okay. So if I have this universe S, okay, I have this universe S, and I have a set called A. Um, the complement, the complement of A is would be A bar. Okay, A bar meaning that whatever is not A. So you can definitely say that from this chart or this graph, A union 8 bar, meaning element of A, element of A bar, or whatever belong to both at the same time is S, right? Because A is this portion here, and A bar is uh, anything that doesn't belong to A, which is pretty, and when you consider both together, that gives you the whole universe um, S. Now let's go to an example. Say for instance, I have a set A, which is 1 and 2, okay, and a set B, which is 1 and 3. What would be A union B? Well, that's simple. A union B, just as we defined it earlier, would consider all the element of A, all the element of B, and all the element of A that belong to A and B at the same time. So the element of A, that's 1, 2. The element of B, uh, that's 3. But also 1 because 1 belong both to A and B at the same time. So that's pretty much that's a simple example to show you how this works. Now, what would be the intersection between of A and B? Intersection A and B, uh, just look at the element that is common to both, which is still B1. Okay. Uh, what would be so? Yep. So say for instance, I have yeah, what would be a bar given that we have the the universe S, which is probably 1, 2, 3, 4, 5, and 6. Well, the complement of A, which is A bar, given that I have uh, the universe S, would be, well, I know that A is 1, 2, so whatever is not A would be 3, 4, 5, and 6. All right, so let's talk about mutually exclusive um, sets. Any set that is mutually exclusive, when we say that two element A and B are mutually exclusive, that means that they have absolutely nothing in common. And let me show you a visual representation of what I mean by two mutually exclusive sets. Okay, so say for instance, I have this diagram, this Venn diagram with S. Okay, I have A here and B here. What do they have in common? Absolutely nothing. Okay, nothing. Nothing that they share together. So this is a case where you have two mutually exclusive set A and B. All right, so I think this is what I wanted to cover for the concept of set, and I hope you like this video. I hope and I really encourage you to subscribe because this is going to be a long journey in my statistics. My statistic tutoring. I encourage you to subscribe to this video and to have more. And also, I do some Python programming tutoring along with the stats course that I'm tutoring. All right. I hope you enjoy it, and I will see you next time. Bye bye.